This is the graph which appears in example 18 in the book, and we're here to find out whether G is a compression or a stretch of the graph of f, and mostly if it's a horizontal or a vertical stretch or compression. Now, if I look at the graph of G, it's actually nowhere. If I look at the highest value of f, which is here, right? If there'd be a stretch vertically, it would actually shift right up or down, and which means that the highest value of G would be higher or lower than that value of 4 for f. So and G is actually at the same height, so I don't see any vertical stretch going on here. However, I see that the graph has kind of been squeezed to the left, so there seems to be a horizontal compression of the graph of f. So a horizontal compression is of the form f of ax. So G of x would be f of x for some a. Now let's try to see if we can find what a is. So my first thing that comes to mind is comparing these 2 points, right? They seem to be pretty well connected. So a G of, if I look at G of 2, which is actually 4, this is the same thing as f of 6. Okay? Now, if G of x is f of ax, that means that G of 2 is a times 2. So that would make a equal to 3. Okay, so this guy here, this is a right there. So this is our guess, like a seems to be 3. So this seems to be a horizontal compression of 1/3 because a is 3. Let's see if that makes sense. For example, this point here seems to correspond to this one. Okay, now this is f of 4, right? F of 4 is 4, and what would be the corresponding x for G that generates f of 4? Well, 4 would have to be 3 times something, right? So if I want to write it as a times x, so I need to write 4 as 3 times something. Now 3 times what will give me 4? 3 times 4/3. So that means it's G of 4/3, which is the same as f of 4. So let's take a look. Like, does that make sense? Does this look like 4/3? Yes, it does. So 4/3 is 1 1/3. So you can actually see this is pretty much 4/3. We can look at other points just to confirm this. Like, for example, 5 gets sent here. So that would be probably 5/3. And that makes sense. This is, yeah, this looks like 5/3. Right, 5/3 times 3 will give us 5. So G of like 5/3 should be equal to f of 3 times 5/3, and that's f of 5, which is 3, and that's correct. G of 5/3 is indeed 3. So that confirms that this is really a horizontal stretch. Okay. So this is maybe what I would write as something like if this is a horizontal stretch, it's actually a horizontal compression. Then G of x is f of ax. So since G, maybe I'll write like my example. G of so what was the first one? G of 2. G of 2 equals to f of 3 times 2. Since G of 4/3 is the same as f of 3 times 4/3, which is, maybe I can write it here. This is f of 6. This is f of 4, and you can write down the last one I found, 5/3. G of 5/3 is f of 3 times 5/3, which is f of 5. So all these have been confirmed, like g of 2 is f of 6, g of 4/3 is f of 4. I'm running out of space here. I'm just going to write it here. Then, whoops, my sentence is not over, so this is like just, then this is, then A, I'm actually just right, then A is 3, and it's a horizontal compression of 1/3. So it's nice to have like calculations that you do on the side, like in your solution, you can keep them. But ultimately, after that, you need to summarize this and write it down nicely. So this is what I've tried to do here. Okay. Okay, and that ends the example.